Alrighty. So I turn off the transcript. Hang on. All right. So again, welcome everyone to our March 2022 presentation. We are excited to have Emelie McKain from Washington Department of Fish and Wildlife presenting on a case study for basin scale climate resiliency. Excuse me. Emelie is a senior environmental planner with WDFW. In her current role, she manages the collaborative development and implementation of basin-wide aquatic species restoration on behalf of the Chehalis Basin Strategy. Her professional focus is landscape scale planning to build climate resiliency and applying ingenuity to complex environmental challenges. Prior to managing the Aquatic Species Restoration Initiative in Washington's Chehalis Basin, she led watershed planning, prioritization, and implementation efforts to conserve and restore oyster habitat for the entire Georgia coast. And once again, thank you everyone and welcome Emelie. I'm going to stop sharing and let you take the lead.
Great, thanks Michelle, and hello everyone. Good afternoon. Thanks for the opportunity to come talk with you all today. I do have a few slides to share with you, so but I certainly don't have, feel free to jump in with questions or comments. I'd love to make this more of a discussion with you all today. So I'm going to try and share my screen. Okay, maybe a thumbs up from Michelle if you can see my screen.
I can see it.
All right, great. Well, we'll dive in. Like Michelle said, I'm with Washington State Department of Fish and Wildlife. Today, I'm going to be speaking about the ongoing effort in the Chehalis River Basin to restore aquatic species habitat and provide climate resiliency at the basin scale. Today's talk is going to be somewhat high level just because we are talking about a whole river basin, but I will give a few project examples and happy to get into the fun technical stuff as interest lays. So to orient you all to the Chehalis, I know this chapter is up in Seattle, so we're not too far away, but this river basin is in the western part of the state. It's situated just between the Cascade Mountains and the coast and sits just south of the Olympic mountain range. It's a low-lying and rain-dominant system, so we do not have any glacial-fed streams in the Chehalis. It's completely seasonal. Just a little bit more about kind of what is going on in the Chehalis and why we're focusing this effort here. The Chehalis is the second largest river basin in the state of Washington. It's got over 3,400 miles of perennial streams and rivers that all drain into Grays Harbor estuary. The river and its tributaries are home to some of the most culturally and ecologically important species in the Northwest region, including steelhead, 2 runs of Chinook. Not sure why my slides keep advancing on their own, sorry. 2 runs of Chinook salmon, coho, and the largest diversity of amphibian species in the state of Washington. So lots of aquatic and semi-aquatic diversity going on in this area of the state. It's also quite notably the only remaining river basin in Washington where no salmon species are listed as threatened or endangered. Unlike our neighboring communities, with Seattle to the north and Portland to the south, the Chehalis is seeing comparably lower levels of development. We do have 4 urban centers spread across a 2,700 square mile basin. What we call the Chehalis Basin today makes up the ancestral lands of numerous tribes. 2 sovereign nations exist today within the basin, the Confederated Tribes of the Chehalis Reservation and the Quinault Indian Nation, which has treaty rights to fish, hunt, and gather within the basin. This basin is a mosaic of distinct communities of people, including commercial and recreational fishers, farmers, foresters, and many more. Apologize, it keeps jumping ahead here. Sorry for the back and forth. It's really focused on, or land use is really dominant in resource-based economies, which really shape this landscape here in Western Washington. And I'd say with all the Chehalis has going for it, I noted the diversity of aquatic species, the low levels of development compared to other areas in the state, and the deep, rich history in natural resources. I, as the project manager for the Chehalis restoration effort, often get the question, why focus intensive, really high cost integrated restoration efforts here? And the next few slides are going to go into really why. The high level answer is that the Chehalis, along with many other ecosystems, but the Chehalis is an ecosystem that's on the brink of climate disaster. We are already feeling very much so the effects of climate change throughout the Chehalis Basin. Existing habitat for salmon has degraded to alarming levels, despite those lower levels of development compared with our neighboring communities. Being a rain-dominant watershed, it will continue to be hit harder by warmer, drier summers due to lack of that available snowpack to feed cold water into the system. And we've analyzed that if meaningful actions are not taken and not taken quickly, our best available science projects devastating effects. For example, the basin's spring run Chinook salmon, an important food source for tribal communities, and orca whales as well, could be extinct by the end of this century. In addition, devastating flooding has been occurring at higher and higher frequencies throughout the basin, which of course impacts communities, transportation routes, and key supply chains along the entire West Coast. Many folks that aren't involved in the Chehalis strategy really know about the Chehalis either because you drive through it on your way north or south on I-5, or you've heard about the Chehalis Basin flooding closing the I-5 corridor. The picture on the right here is one instance of I-5 closing due to severe flooding in the area. And in one instance has shut down I-5 for several days at a time. So that's how we hit the national news, really garner a lot of attention to the Chehalis, but it's not the only thing that's happening in the impacts of climate change. Due to the degradation of aquatic species habitat combined with the significant and more frequent flooding events happening in the basin, the Chehalis Basin is, of course, facing a climate challenge, but it's also, in my mind, a perfect case study for building a movement toward climate resiliency at the basin scale. As I mentioned, we're the second largest river basin in the state of Washington, so it's a pretty big case study to see if we can really move the dial in a positive way. The Chehalis Basin Strategy, which is a collaborative effort, is striving to broadly integrate both enhanced flood safety with aquatic habitat restoration. This initiative was launched in 2010, to address two of the basin's greatest climate challenges, that precipitous decline of salmon and their aquatic habitats, and the certainty that catastrophic flooding will once again devastate the basin. In the Chehalis, our collaborative leadership team has aggressively pursued those two goals of reducing damages from future flooding events, as well as restoring aquatic species habitat. But they've also gone a step beyond just kind of identifying those goals, and particularly around the aquatic species habitat side of things, looked at this effort as an opportunity to build that basin-wide ecosystem resiliency and really look at foundationally what is needed throughout this basin, throughout the system, to be resilient not only now but into the future. So the Aquatic Species Restoration Plan, or ASRP as I'll call it from now on, we at the state love our acronyms, so I'll introduce another here for you today, is a key component of our overall Chehalis Basin strategy. It's that one half of the strategy focusing on aquatic species habitat. It's led by the collaborative vision of our two tribal nations, the Quinault Indian Nation, Confederated Tribes of the Chehalis Reservation, as well as state and local governments and agencies. So WDFW, along with Department of Ecology, play key roles in the leadership of this program as well. This plan will attempt to implement around 550 miles of priority in-stream habitat and restoration protections to not only curb the effects of climate change being felt now, but provide that resiliency that's needed into the future. It is a science-based plan. So while we published a phase 1 report back in 2019, we spent about 7 years really collecting baseline data to inform the strategies and priorities that have been identified in the plan itself. The link at the bottom of the screen here, and I'm happy to put it in the chat later, is to our website where you can, of course, find more information about the plan and what we're up to. A little bit more on development of the plan itself. When I mentioned before, we have a 2,700 square mile river basin. We had to think very strategically about how to develop habitat priorities across a landscape that large and really that diverse. We have, while the entire basin is somewhat low-lying, there are different habitat attributes and physical constraints depending on where you are in this area of the state. So what we did was break down the basin into 10 distinct, what we called ecological regions. Those are mapped on the right here. And those are based on underlying geology, topography, localized climate conditions, and in-stream channel characteristics. That helped us both organize those baseline conditions and all that data we collected in the early 2010s and compare priorities both within and across these various regions. We then used a two-model habitat model approach to assess limiting factors and compared those limiting factors to those baseline conditions under both a current condition timeline, so what's on the ground out there today, and under future climate change scenarios. This work resulted in the identification of location and action priorities that have the most potential for uplift for native species in the face of climate change. So again, we're really looking at those late scenario outcomes under climate change. Lastly, we underwent, I'd say, a pretty rigorous prioritization and sequencing effort where, we identified not only our priorities across the basin, but said, okay, where do we put investments first? Where do we put our first, nickel, so to speak, and second and third, so that we are strategically implementing projects that we know need to be on the ground now in order for processes to be enacted in the ecosystem and in place in the future. So all of the development work that I just highlighted resulted in really the prioritization and sequencing of 550 miles, or about 15% of our perennial streams throughout the basin, and then sequenced those priorities to address the highest limiting factors first in each of our subbasins. The map on the right, shows as an example the first select subbasins that will be implementing projects throughout this through this program. So the yellow, or at least it's yellow on my screen, yellow polygons here show our immediate priority areas. These are areas that we've prioritized for specific reasons, such as in the lower right-hand portion of the map here, which is actually the upper basin. The river flows from south to northwest in this instance. The yellow polygons to the southeast here are really prioritized for at-risk species. So these are our stronghold areas for spring Chinook salmon, which, as I mentioned earlier, are facing a very significant decline in population and distribution. So we've highlighted those areas as core habitat to enhance those habitats for spring Chinook and provide resiliency for those habitats into the future so that we know that those habitats will persist without human intervention. We've also prioritized areas based on physical constraints or limitations, such as water temperature or availability. Another coinciding limiting factor with spring Chinook is actually water temperature. Areas like the Newaukum and the Skookumchuck, or especially the Newaukum down here in your southeast portion of your screen, are seeing higher and higher water temperature rates, which is a significantly limiting factor for salmon and steelhead. Doing actions now to overcome, stream temperature and flow constraints will not only help enhance conditions for those aquatic species like salmon, but provide that condition and those habitats well into the future. The ASRP, I mentioned this 550-mile goal. Through our climate modeling, we've also identified the timeline goal of implementing this full breadth of restoration and protection within 30 years. And the clock is currently ticking on that because it started earlier this year. This is really to, as I mentioned, combat the effects of climate change and try and get ahead of the curve. We've also prioritized types of restoration that are meant to kickstart ecological processes in these stretches of the river that we've prioritized. So one thing that I'll mention in a few slides is the notion of a reach scale restoration approach, or reach scale restoration project, where it's, say a 2 to 3 river mile stretch of river that might be one project. And throughout that 2 or 3 mile stretch of river, we might be implementing several restoration treatments, both in stream, side channel, wetland, as well as riparian components, so that we're kind of combating the suite of limiting factors across an area large enough to enact natural ecosystem processes and really kickstart those to function on their own in the future. So as I mentioned, the clock is ticking on implementation. We have moved from developing this ASRP and our plan and priorities to implementing and adaptively managing those priorities. So we're taking those scientific priorities and curating partnerships with landowners to enact large-scale restoration projects, hopefully at a pace not yet attempted in Washington state. Unlike many of the state's more forested watersheds, over 80% of the Chehalis Basin is in private land ownership, and as I mentioned earlier, in largely resource-based land ownership. So implementing those 550 miles of restoration in just 30 years with willing landowners is our greatest and next challenge. We do not have a regulatory nexus for this program, so we are really relying on partnerships with willing landowners to enact this important work. As we developed the plan itself, we also developed a few pilot projects to help understand our ability to get these large scale or reach scale projects on the ground. We enacted five reach scale projects, which are slated to restore up to 13 miles of core aquatic habitats. And through partnering with landowners around the basin, we're now transforming those landscapes and turning their landowners' vision for their lands into a reality while creating habitat and kickstarting natural riverine processes. So a few other kind of comments on this program and some of the, I think, really fun and innovating ways that we are looking at implementing the ASRP is through, one, collaboration and leveraging of funds. I mentioned earlier that the ASRP is one half of the Chehalis Basin strategy. The rest of the strategy is dealing with and trying to come up with solutions to reduce damages from flooding throughout the basin. The strategy isn't attempting to stop flooding, as it is a natural occurrence, but rather work with communities to reduce damages from flooding. And one of the pilot programs being developed throughout, other initiatives in the Chehalis Basin strategy is an erosion management pilot program. We're working with landowners to address significant bank erosion conditions or considerations is being developed. One of the great collaborations that ASRP provides is a nexus to say, what funding really fits within habitat restoration and the slowing of channel migration rates versus a true, more infrastructure erosion management project. And how can we leverage funds to help landowners with maybe infrastructure risk or protection needs, but also increase habitat or better conditions for habitat for aquatic species. So it's great to see partnerships being made across these two objectives of the strategy. We're also really partnering with other programs around the region and the state. The ASRP and the Chehalis Basin strategy is a relative newcomer on the stage of salmon and habitat restoration and protection. And so we're working with programs, more acronyms for you here, but the Salmon Recovery Funding Board, the Fish Barrier Removal Board, and so forth, to leverage funds and be able to contribute to projects that will have the benefits that we're seeking to achieve through ASRP. One of my favorite opportunities to innovate through the ASRP is through experimental restoration. So we have a huge charge of 550 miles of restoration. We have a even larger charge of getting it done in a 30 or so year timeline. And what these goals are in the program is really connected to, as I mentioned earlier, our limiting factors, or what we know are kind of our largest obstacles to providing habitat that is self-sustaining and resilient to climate change for our native aquatic species. One of the ways that we are trying to ensure that the investments made are resilient, are adaptive, is through experimental restoration. These are, considering either new restoration methods or bringing in maybe tried and true methods from different areas in the state or region that haven't been tested in the Chehalis Basin or these specific habitat contexts. Some examples here include sediment wedges, which are actually a somewhat new or novel idea. It hasn't been tested yet in the Chehalis Basin, and we have 2 sites going to construction summer of 2023. Sediment wedges, in the context of the Chehalis and ASRP and how we're testing them, are really a focused version of an engineered log jam. Engineered log jams are typically, several or many large tree trunks with root wads still attached, driven and kind of woven into a stream network to provide pool habitat and scouring so that we're aggregating gravels for fish to spawn in and so forth. Sediment wedges kind of pare down that approach to target the amount and load of wood that's put into a stream, and also think about the context of the stream that it's put into. So the picture on the upper left here is actually one of our sediment wedge sites. And this is an area in the basin that has graded down to bedrock. And so there isn't any sediment retention happening in this area. The groundwater flow is incredibly limited. And as a result, we get a lot of surface flow that fluctuates throughout the season and that heats up very quickly. This is one picture. There is a little bit more of a riparian cover, but lower down the stream, the water just gets hammered by summer sun. So what we're aiming to do is install a very focused and smaller, essentially engineered log jam to promote the retention of sediment behind the logs itself, or the log itself, and drive water down into the ground table so that we're actually, increasing groundwater flow. We're promoting that infiltration to happen. And through doing so, we're hoping that we can influence the temperature outcomes lower in the stream by reducing the temperature in this reach. So this particular component, like I mentioned, will be constructed next summer. There is a monitoring component attached to this experimental restoration, which will allow us to understand not only the outcomes at these two sites, but see, if it's a good opportunity to potentially scale up around the basin and use to help combat water temperatures where stream conditions have degraded down to bedrock, and we think a sediment wedge could be a good application there. Another experimental restoration technique we're trying in the Chehalis are beaver dam analogs. This one is a bit more well known in the restoration world, particularly on the east side of the Cascades in Washington. They're very much used in more open, shallow streams, but haven't been used west of the Cascades much, especially for how we're hoping to use them in the Chehalis, which is multi-benefit. The picture on the lower right here is one of our future sites for a beaver dam analog installation. And a beaver dam analog is essentially a man-made beaver dam. It will, in context of the ASRP, we're hoping that, not only we're targeting areas that beaver naturally occur in and could maintain the site over time, but we're actually looking to pond water behind and re-engage what we have identified are historical wetland complexes. The wetlands are typically, they provide great rearing habitat for young salmon juveniles, as well as other aquatic critters that don't get, as much attention when the focus is often on salmon. So amphibians are a great multi-species benefit from these types of projects. So two, I think, pretty fun things happening because the ASRP has this overarching kind of goal of figuring out how we can not only enhance aquatic habitat for native species, but really think about how to make these habitats, or how to increase resiliency of these habitats to increasing climate change impacts. We're able to try new and innovative methods to be able to, test whether we can actually get there in the time that we've allotted to. The last example I'll give is on kind of innovation or opportunities to be creative through the ASRP is bridging gaps between recovery priorities. As I mentioned at the beginning of my talk, the Chehalis does not have any federally listed threatened or endangered salmon species. This creates a somewhat different recovery priority than established basins that do have federally listed salmon species. We don't in the Chehalis, for example, have numeric targets on number of fish that we are hoping to support through this habitat restoration work, but we can have multi-species benefit outcomes, and that's something that through restoration techniques and the size and scale of projects that we've really hoped to accomplish throughout the Chehalis. We also have, I think, some great statewide synergies with ongoing recovery priorities. Spring Chinook salmon being a species of a special focus in recent years in our state's legislature, an appropriation of funding, being such a focus on promoting and supporting that species. That's one that lines up really well with statewide priorities, as well as looking at water resources and the recently passed Stream Flow Act. The temperature and flow issues that I mentioned earlier are of increasing importance throughout the Chehalis, and we're looking not only to leverage those priorities, but contribute funds to projects that have multi-benefit stream flow outcomes. The maps here on the right show, one on the left is actually, these are both stream temperature models that were created specifically for the Chehalis. The one on the left is current stream temperatures, where the thermal representation is blue is colder, red is hotter, and the colors in between are increasingly so. So you can see our main stem Chehalis is already in that red zone of over 20 degrees Celsius in as a mean August stream temperature. Already some getting toward lethal levels for salmon and other native species. And you can see the distribution of red significantly increase when we look out to 2080. This is something that we have used to prioritize specific temperature and stream flow projects in the basin, so that we're approaching these areas right now and not being reactive when it's already too late. So just briefly, next steps, as I mentioned, we're shifting our energy toward full implementation and adaptive management. The ASRP has about a $20 million project budget for the 2021-2023 biennium, and we are filling that budget with priority projects as we speak. So working with local organizations to enact restoration and protection projects that align with our program priorities. Also, continued collaboration with landowners throughout our priority areas is ongoing and growing as we speak. I'd like to mention also that the ASRP is designed to be adaptively managed. The Chehalis Basin strategy as a whole will intensively monitor our progress and adjust not only funding, but resources that might be needed over time. The robust development process that we underwent, our transparent project and priority areas, and our ongoing monitoring of projects and our ability to implement will also set the program up well to be a case study, in certain increments of time to see, what, depending on the question, what has been accomplished. Have we been able to implement at the scale or at the pace that we set out to? Are we getting the benefits that we hope to get out of our priority areas? So I think that the way that this program is structured, depending on the scale and the types of questions, will be a great resource for other programs in years to come. Lastly, I want to plug an upcoming symposium event for folks that might want to learn more about the scientific advancements and more of the technical details, some of that stream flow monitoring or anything like that. We are hosting a symposium this April, April 20th and 21st. I will put the link here in the chat to get registered. It's a free event. 2 half-day sessions, 9 to 12:30 or so, and it is virtual. So you're welcome to pop into a particular section that is of interest to you, or if you're learning, or if you're interested rather in learning how to get more involved in this effort, how to plug your organization in, there will be sessions targeted toward that as well. So with that, I'd like to thank you all for lending me your ear over the lunch hour. I'm happy to take any questions. Really appreciate the opportunity. Thank you.
Thank you so much for that. Great. With that, we'll open up with questions. Feel free to turn on your camera and ask, or if you'd like to type it into the chat. If people ponder, I'll ask the first question. I know some people need some time to think. I guess my first question for you is, you'd mentioned a few of the metrics that you guys are looking for, let's say, for success, whether that be the number of fish or your temperature dropping, or your sediment load, et cetera, et cetera. I guess, what is your timeline for measuring success of these pilot programs? Like, are you monitoring in a year, 5 years, 10 years? Ultimately, I know you mentioned, several years, but I guess at what point do you say, this is working, let's keep going, or ooh, not so much?
That's a really good question, and one I think we'll continue to answer as we do get more projects on the ground. I'd say the timeline really depends on the research question being asked, particularly for project effectiveness. Some of those experimental restoration techniques I mentioned, we have a 5 to 6 year monitoring period for those, both before and after project construction. So we do have, a several season data collection effort and then analysis to really understand over time, how are these projects performing, and what can we learn from them to apply elsewhere in the basin. In terms of metrics of success of the program overall, in terms of biological outcomes, number of salmon supported, or number of frogs that are in the basin, those biological trend lines take much longer to establish. So those, we've identified it for a 10-year timeline to establish those trend lines and really understand, are we heading in the right direction? Do we need, some course correction, that sort of thing. But all that to say, we're going to be focusing the majority of our monitoring on physical components, so that we can have a slightly shorter timeline and that we can adjust very quickly for the next sort of round of projects if need be.
Great, thank you. Robert, I see your hand is up. I'll let you go next.
Thank you, Michelle, and thank you, Emelie, for your fantastic presentation. My name's Robert. I'm a H&H engineer, just graduated recently with Kleinschmidt Group. And I'm also a ASCE YMF officer down in Portland doing volunteer stuff, so it's pretty fun. I always had a general question about restoration, and it was interesting that you brought up, the two main methods. The one being reducing water temperatures to get below that 20 degrees C to increase the suitability of habitat, but also you mentioned creating those beaver analogs, or the beaver ponds, which of course increases retention time of water in the basin by creating those ponds. So I was wondering how you manage both reducing temperature, but also creating those beaver ponds that increases retention time and may increase water temperature. I know it's kind of like a increase decrease situation, but I was always wondering what you think about that, especially in such a huge basin-wide implementation that you're trying to do.
Absolutely. And Robert, I mean, good catch on that. Essentially the catch 22 of reducing stream temperatures, but also looking at retention of flow throughout the year. And I think due to the diversity of conditions throughout the basin, we've actually been able to prioritize specific locations for each of those individual treatments. So, for instance, a beaver dam analog and a sediment wedge would not go in the same stream, because that would kind of, in some instances, have negating effects, right, of lowering the temperature and then ponding it. And so we've prioritized specific areas depending on the top limiting factors to address those given the treatments available, and then testing these sort of new or innovative ways as potential scalable treatments as well.
Awesome, thank you.
Thanks, Robert. Ray, I see your hand is up.
Yeah, hi, this is Ray Walton with West Consultants. Could you talk about the species restoration against the possibility of a new dam being built on the upper part of the middle Chehalis?
Thanks for the question, Ray. And for context, Ray is referencing one of the potential suite of actions that's being considered on the flood damage reduction side of the strategy. So within the Chehalis Basin strategy, there are several actions being discussed and considered to reduce damages from flood impacts. And one of those is a flood retention center, otherwise known as a dam. That project is still in feasibility analysis. So they're undergoing SEPA and NEPA analysis on that project right now. So I cannot tell you whether it will be constructed or permitted or whatnot at this point in time. What I can tell you is that if the Chehalis Basin Board, our collaborative leadership team, decides to pursue that flood retention facility, that the aquatic species restoration plan would not be the mitigation for that facility. What they've determined is that not only will that facility need an appropriately scaled mitigation plan, but the aquatic species plan, the ASRP, would be above and beyond that. I will say that we've developed the ASRP in the absence of a new dam being put in on the main stem Chehalis. It's sort of hard to develop a program and allocate funding toward projects on a might be basis, right? Or like if something could happen in the future. So we've progressed our program with the known facts that we have, and we'll adjust as new obstacles or new challenges come online.
So, any other questions either you want to share vocally or put in the chat? Maybe. There we go. Robert?
I have another question for you. I did some kayaking around Payel. I hope I'm pronouncing that correctly, on the upper Chehalis River. And I noticed that there's many places where bedrock intersects the bottom of the stream bed, especially kind of around the Rainbow Falls area. I was wondering how much like bedrock and the essentially non-ability to move around sediments and kind of dig in the sand, play in the sand per se to create projects, how much of that is an impact for your analysis and your study?
A great observation while you're out there, because it's not always very clear in that area. I'm glad you got out there on a clear day, or at least the water being clear. The bedrock prevalence in the upper basin is certainly there, and is a constraint for habitat restoration designs. I'm speaking to an audience that is much more technical than I am, so I won't pretend to know all of the modeling and engineering speak, but we in areas that have constraints like exposed bedrock, it does take our project teams and engineering teams, I'd say, a bit more consideration on what the real feasible outcomes are in a site like that, or with site conditions like exposed bedrock. Obviously, it's much harder to drive piles into exposed bedrock. So thinking about alternative ways of anchoring large wood to help retain sediment and scour out some areas and really hold back some gravels for spawning and rearing for fish. Those are considerations that we have every day. I will say it's not as depending on where you are in the basin, because it's so big and diverse, we don't have that issue everywhere. It is more of an issue in the upper, especially main stem areas, as lower lying tributary systems.
Thank you.
Any other questions? Twice. Don't see anything in the chat and don't see any other people's hands up. Well, thank you very much for your presentation. I appreciate it. I'm gonna just send a reminder or give a reminder of our next presentation, but if you don't mind dropping in those links that you were talking about before everyone loses access to the chat, that would be great. In the meantime, for everyone, a reminder that our meeting next month is April 21st with Dr. Kirk O'Reilly from Exponent. I don't have his topic yet, so that'll be to be determined, but look for an invite again over email. Again, that's April 21st. So thank you again, everyone. Thank you, Emelie, for your presentation, and everyone have a great day. See you next month.
Thank you all.
Thank you.